Hey guys, Mr. T here, just doing another video on sample space. So the sample space of an experiment is a set of all the possible outcomes in that experiment. You can display the sample space in a number of ways, but the three we're looking at this stage are lists, grids, and tree diagrams. So let's look at lists first. Cat's being noisy. What is a list? The simplest way to represent a sample space is to list the possible outcomes in a set. You indicate a set of numbers with curly brackets like this. So for example, if I was rolling a 6-sided dice, the sample size of it is going to be 1, 2, 3, 4, 5, and 6. Those are the possible outcomes of rolling that dice. But if I want to indicate it properly, in probability and chance, I would have a curly bracket there, 1, 2, etc. up to 6, end curly bracket. So that's the easiest way. Obviously, that's not going to be very good if there's tons of outcomes. So that's why we go to the next thing, which is a grid. A grid or an array is a more efficient way to represent the sample space in an experiment involving two variables specifically. You don't want to go any further than that because you're only going to be able to work with two axes. So the sample space for flipping a coin and rolling a 6-sided dice is. So you can see there's two variables here, the coin and the 6-sided dice. So each one of these axes in the grid represents one of those variables. So I'm going to have the x-axis be the coin, the y-axis be the dice, and then the blips or the scale markings on the axes represent the different possible outcomes on those variables. So on the coin, I've got heads and tails. There's only two things that the coin could be. On the y-axis, it's a 6-sided dice, so it could roll 1, 2, 3, 4, 5, 6. So the key with a grid is that each dot on the grid represents a specific outcome. So let's do an example. This circled one here represents flipping on the coin. In what column is it? It's in the tails column. So flipping a tails and rolling. Where is it on the y-axis? What row is it? It's on the 2. So and rolling 2. So that's an example of reading a grid. It's pretty basic, but you need to be aware of it. And then lastly, the other kind of the other way that we're going to display sample space is a tree diagram. And you're probably going to work with these the most later. A tree diagram is used when an experiment has more than two variables or steps for each outcome. So you can use it for two variable stuff as well. So it's just gonna work for the most different things. It just takes a lot of space to draw. So let's say the sample space for flipping a coin 3 times. So you can see it's more than the 2 which we dealt with in the grid. Let's flip a coin 3 times. So what is a tree diagram of that? It's called a tree diagram because it looks like a tree. All these lines are branches, and at the end of those branches are the different outcomes for each of the variables or each of the trails. So in this case, you're flipping it 3 times. So each of these steps has to represent one of those 3 variables. So our 3 is the flip 1, flip 2, and flip 3. And so on flip 1, what are the possible things that could happen? On flip 1, I could flip a head or a tail. On flip 2, I can flip a head or a tail, but that happens after, on this particular set of branches, that head or a tail happens after I've flipped a heads on flip 1. Okay, whereas this set of 2 branches is me on my second flip, flipping a head or a tail, but that's after I flipped a tail in the first flip. So you can see why it widens, because in flip 1 there's only 2 things that could happen. In flip 2 there's 4 separate sets of events that could have happened. I could have flipped a head and a head, I could have flipped a head and a tail, I could have flipped a tail and a head, and I could flip a tail and a tail. And then it gets infinitely more, well, it gets not infinitely more, it's just going to get significantly more complex each time. So on flip 3, I could have flipped a head and then a head on the second flip, and then on flip 3 I could flip a head or a tail, and etc. Each one of these occurrences on flip 2 is going to have 2 more branches coming out of it. So each trail of branches represents an outcome made up of the steps in the experiment. So let's just look at one set of branches. If I was to look at this trail here, that trail there, what does that represent? Represents flipping a head, and then a tail second, and then a head last. So that's how you read a tree diagram and draw one. And hopefully that helps you out, and I'll see you in the next video.